This one? Is it this one? No. Oh, I see it. Gotcha. Thank you. Thank you very much to Talib for that very informative discussion. Our next speaker is Joseph Lubin. Joe is an entrepreneur and co-founder of the well-known blockchain computing platform Etherium. He's the founder of ConsenSys Systems, a Brooklyn-based software studio building decentralized applications. For those of you who don't know, ConsenSys is one of the largest and fastest growing companies in the blockchain. Welcome to Joe.
Thank you. Thank you to Tyler for having me and all his friends here. It's a great event and a testament to Tyler that he can get all his friends here. It's quite a program. So November 2008, 2009, Bitcoin happened. Bitcoin was a breakthrough in computer science. It essentially enabled groups of people to come to a decision, even if up to half of those people were malicious in intent. So that technology was applied in a single use case to essentially a money system or a payment system. And we will see, as the gentleman trader will probably be excited about, that there are many more use cases, including programmable blockchains. 2012, people like me and many others started thinking about how to apply that technology, the blockchain technology, to a wide variety of use cases. Many different technologies were attempted, and Vitalik Buterin, the inventor of Ethereum, was working on a bunch of those projects and came to the conclusion that they were all approaching the problem in an unscalable fashion. They were all either trying to add one use case at a time at the protocol level or perhaps at the client level. And with all of the use cases that we could possibly apply to blockchain, that would take far too long. So he took a step back. He wrote a white paper describing the Etherium Platform. The Etherium Platform is basically a platform for decentralized applications and programmable decentralized applications. So the project started in January 2014. We raised funds in a crowd sale and earned $18 million in that event. Applied that money to the development of the system, and July 30, 2015, Ethereum version 1 client was released. About 20 months later, it has become the second most popular, second most valuable blockchain system. It's currently protecting about $4 billion in its monetary base. So as I indicated earlier, Satoshi Nakamoto, person or group, inventor of Bitcoin, set out to conduct an experiment in monetary theory. We at Ethereum set out to build a platform for decentralized applications. As a software platform, we need to make things editable. So for the trader who is concerned about immutable transactions, you can certainly update data on a programmable blockchain. And as a platform, we need to be agile. So it makes sense that the Bitcoin code base moves glacially slowly. It should move a little bit faster, perhaps. But for a platform that needs to be responsive to new technologies, the Ethereum platform needs to be agile and move forward quickly. So one of the main breakthroughs here is that the Ethereum project has built the first general purpose world computer. So it's a platform that we can all upload programs to. if you're sufficiently technical, and access programs, similar to the internet, except they are all sitting in a single execution space. So the synergies between all those programs will be quite profound as it gets built out. This technology enables both the public permissionless blockchain and also private permission blockchains built on the same technology. By solving the hard problem of essentially enabling consensus among state changes or the next state of the network in the difficult public context, we easily solve those problems in the private permission context. And as Tyler indicated earlier, or I think it was Will indicated earlier, the ability to use the same technology essentially in your private permission systems and the public blockchain is going to prove invaluable over time. So these blockchain systems are composed of 5 different fundamental elements. The first is the blockchain database itself. It's essentially a database that enables the sequencing of transactions so that you know what happened and when. That's pretty close to the non-repudiable or immutable element. Towards the head of the blockchain, there's some mutability as things settle in, but the canonical history is what's immutable. Both Bitcoin and Ether and other cryptographic systems have a cryptographic token based on public key cryptography. It's composed of 2 elements, a private element and a public element. The public element basically serves as that address that appears to own some value, and the private element is what controls that address or controls the value ultimately. These systems are architected on peer-to-peer networks. That turns computing from what we've seen for decades and what we see on the internet, an architecture called client-server architecture or star pattern architecture, to a peer-to-peer or more robust mesh network kind of architecture. All these systems have a consensus formation algorithm. As I indicated before, solving the problem in the hard context is incredibly powerful because it enables easier solutions in the private permissionless context. And when you do move to that private permissionless context, you can relax assumptions, make simplifications, do optimizations, and increase performance or scalability dramatically. The distinguishing element between Ethereum and other blockchain systems is the nature of the virtual machine and the high-level programming languages. So Vitalik's essential insight was to put a computationally complete or powerful virtual machine at every node of that peer-to-peer network. And many of us now have put together high-level languages that compile down to the bytecodes of that virtual machine and enable powerful programs to be built. So the core value proposition was really that we were able to separate the complicated protocol layer from the application layer and enable average software developers instead of cryptographic or cryptography and computer science specialists, so millions of average software developers, to focus just at the application layer, identify their own problems and build their own solutions, and use a programming technology that looks very similar to what they would use in building web applications or mobile applications. So why is public blockchain important if you're only interested in private permission blockchains? Our company ConsenSys, we're split, again, to answer another question from earlier, we're split about down the middle in terms of the products that we build for public blockchain and the work that we do in private permission blockchains for our consulting clients. So I do think 50-50 is probably a good split at this point. So when we do speak to our consulting clients, they have a few options. There's some proprietary systems. There are systems that are open source. One system driven by IBM mostly is called Fabric under the Hyperledger Foundation. So why is public blockchain important when you have all these other candidate blockchain database systems? First, having a public value token, the Ethereum token, and let me back up a little bit. The Ethereum token is more functional in a sense than the Bitcoin token because people can upload programs to the public blockchain that could potentially contain infinite loops, and because people can upload data to the public blockchain and possibly excessive amounts of data, it is required that every computational step and every storage operation require the payment of a tiny slice of ether. So this value token was sold basically as a way of accessing the public blockchain. An interesting side effect is that you have lots of software developers and business developers who hold this value token and who are incentivized to increase the value of the ecosystem. So it's been a driver for many different projects in the public blockchain space, public Ethereum space. One of the early killer apps or first exciting use cases on Ethereum are crowdfundings, token launches, and equity token launches, although sometimes we look for structures that wouldn't be called equity by certain regulators. There is a bit of a gold rush going on right now. Many different startups are using mechanisms. We at our company ConsenSys have built an equity crowdfunding platform called Wayfund, and we built a governance tool called Boardroom to enable these sorts of things. And these startups are making use of these mechanisms. First implication there is that it's going to unlock a tremendous amount of frozen capital. So it's very hard, unless you're an accredited investor, to put money into projects, exciting projects, in the Western world at least. But this will enable permissionless investing. University students can put $100 into a token launch, and that's global, so it's going to thaw a lot of frozen capital. On the other side of that, we have a lot of startups who can't get an email back from a VC. This has enabled permissionless venture capital, where all you have to do is get organized and put your pitch up on the internet and arrange with one of these platforms or build your own system, and you can token launch your own company. And this is happening. This is happening today, actually, for one of our companies, a prediction markets platform. Bank code systems, medical code systems, they're scrutinized by a fairly small number of eyeballs. These public open source systems are highly scrutinized, not just by the developers, but also by security consultants from around the world who are trying to steal money from these systems. So these systems are have the ability to be incredibly well hardened. Finally, with respect to blockchain, or with respect to private permission networks and blockchain, it is foolish, in my opinion, to choose a stack, develop expertise, and then build an infrastructure on that stack unless it has a clear path to being a public blockchain. And there is, in my opinion, no way to go from a private permission blockchain to becoming a public permissionless blockchain, the crypto economics are just too difficult. So you have to start with the public blockchain and then make those simplifying assumptions. If you need 10,000 transactions per second, that can be done. You just have to make some changes for the strong governance situation, and then you can use the same technology as the public blockchain. So the most important thing for an ecosystem, in my opinion, in technology is developers. The Ethereum project is significantly in the lead in that respect and is experiencing tremendous network effects. So this is an old slide. We're at about 60,000 downloads of our developer tools. We at ConsenSys have built a pretty exciting stack of developer tools for our ecosystem. So what exactly is a decentralized application? It is a front end and a back end, just like a regular application. The front end is roughly the same as a regular application. It can be a web front end, it can be a mobile front end. The back end is where it's different. So the database in this case is a smart contract or a set of smart contracts. It's a terrible name because they're not smart and they're not contracts. They're essentially software blobs executable in the virtual machine on the blockchain, and every node on that peer-to-peer network runs the same code and comes into consensus about what happened and when. And the state of the system is changed. For Bitcoin, the state moves ahead about every 10 minutes. For Ethereum, because it's a decentralized application platform, that would be pretty frustrating. So state moves ahead about every 14 seconds, and that's dropping pretty quickly over the next few releases. So the simplest way to view blockchain, in my opinion, is as a next generation database system. Currently, we build information systems on top of database technology that constrains what they can do in terms of sharing. That's the way businesses construct the tools that they need to run their operations. This new technology, because every actor on the system, whether it's the public blockchain or private permission blockchains, has access to all the data, and for Ethereum, access to all the business logic in the form of those smart contracts that operate on the data. In that situation, everybody can feel comfortable that no minority set of actors can improperly manipulate the data or the business logic. And so we've been calling this veridical, or ever pertaining to the truth, or trust minimized computing. And it's a context that enables us to move from businesses building their own siloed systems to industries building shared infrastructure. And they can do that because everybody can operate on this shared infrastructure and trust it. Another interesting aspect of this technology for businesses is that in contrast to current architectures, which are ring-fenced, firewall ring-fenced architectures protecting soft assets in the form of different kinds of databases, we see that these sorts of architectures are regularly penetrated by hackers. This architecture requires a strongly cryptographically authorized and granularly authenticated and granularly authorized transaction every time you interact with the system. So you've got strong cryptography baked in all the way, and there is no way to get into the system and then have free reign over everything in the infrastructure. So if you combine this veridical computing nature, the fact that we can trust this new shared information system, the peer-to-peer context that it's executed on, and the more secure IT infrastructure that it implies, and we realize that peer-to-peer networking architecture essentially provides a free market, a low barrier to entry kind of infrastructure. then we can see blockchain as a force for universal disintermediation. Intermediation is a great thing when it reduces the costs of transactions, adds value to a transaction, reduces time or friction. But intermediaries tend to impose themselves into a transaction and then increase the spread between what they extract and the value they add to that transaction. So we're going to see this applied to every industry at every level, squeezing some intermediaries out or shrinking their dominance in many different situations. I see all of this as a driver for tremendous growth in our economy. So there are a few challenges. Scalability, blockchains process every transaction, store all data. Ethereum has a roadmap for that will take us to an infrastructure in which we essentially have lots of different blockchains, lots of different Ethereum blockchains that are all kept consistent with one another via some complex cryptographic mechanisms. There are a handful of other technologies enabling both increased scalability. One important one is called state channels that enables you to do transactions off the blockchain after having initialized the transactions with basically escrow into a smart contract, and then you can finalize the transactions at some point in time, could be months later, by settling up. And privacy and confidentiality are also being dealt with. So there's one Ethereum architecture built by JP Morgan and the Go Ethereum team that enables sets of actors to have private transactions among themselves. And there are more sophisticated techniques, more general techniques that will be available very soon in Ethereum, very soon, in a matter of months. So ConsenSys is a company that I started 2.5 years ago to build product for the public blockchain. A year into the project, I wound down my activities on the foundation because it was clear that we were going to release version 1, but nobody was building applications. So I took that opportunity to bring people together, do some researchy projects, build some POCs, intending to be a venture production studio where we would build projects into products, into companies, and attempt to grow the ecosystem that way. About 2 years ago, we started getting calls from enterprise and asking for assistance with strategy and building out or ideating use cases, building out POCs, et cetera. So as I said before, about half our company does enterprise consulting in the energy industry, advertising technology, healthcare, supply chain management, et cetera, and financial services, of course. So currently we're a little shy of 200 people in 17 countries. We have 5 offices at this point. So one of our favorite projects was with Tyler, a supply chain management system or provenance system. I have a feeling he'll be talking about it at some point soon, so I'll jump through. A nation state somewhere not too close to here is building a land registry system. We are building that for them. It's an exciting project that we will go public with fairly soon. Let me jump to, how much time do I have? 5? Okay, cool. So some interesting implications. One is for identity. For the first time in history, we have a shared global database, permissionless, that we can all perhaps trust because nobody can improperly manipulate it, we believe. Trust to be a substrate for global identity. It would be quite dangerous, I think, if you created a centralized global identity database. So we've built a product called Uport. It's an identity construct. It's intimately associated with a reputation system that we built. And we've enabled people around the world, anybody who has access to the internet, to establish their own blockchain-based self-sovereign identity. Our identity construct is a container for reputational attributes, so you can upload, say, your state-issued ID into the system. You can then link your blockchain-based ID, which enables easy access to decentralized applications or passwordless, username-less access to regular applications if they're configured well. It enables you to link that blockchain-based identity to your legacy world identity. So in order to do that, you can go to an identity provider like a government agency or a bank, or one of the early attesters are going to be exchanges, companies within the blockchain ecosystem that have already KYC'd people. So you can link your identity to the legacy identity provider infrastructure. In addition to attributes, you can also have attestations, reputational attestations. So as you engage in different kinds of transactions, whether on the blockchain or even off the blockchain, feedback regarding your conduct in those transactions can be lodged in the form of a cryptographic attestation by your counterparties. So if you pay back a loan, if you work together well on a project via our boardroom governance tool, or any other sort of interaction, can be used to form a persistent portable reputation. So this is something that you can sort of carry around with you without carrying it around with you. It is everywhere. You can leave your country with no possessions and access your identity and your reputation across the border somewhere. So we believe that this technology will enable people in the developing world to bootstrap themselves into the new economy. And we believe that this technology is a better form of identity for people in the developed world, because they will own all the elements of their identity, all the aspects of financial information or healthcare information that they can upload or authorize uploading. All of this data will be held encrypted and selectively disclosable for situations that they authorize. Should I stop there, or can I do one more? Sure. So, let me just stop there and take questions. Go ahead.
Hello, Tom from Storage. I'm curious if you could tell us a little bit more about the transition from finding out about Ethereum, being involved in the foundation, maybe to build a company to build applications or something like that.
Yeah, actually wasn't just my idea. We started the project intending to be crypto Google. So the idea was that we would build this platform, we would put it under, we would open source it, we would put it under a foundation. And then that same group of people, warm, friendly, cooperative people, would work together and build lots of for-profit projects and perhaps companies or within one company. So there were lots of challenges. We kept the project together because we all were aligned in our broadest goals, but there were lots of complications on the project that made us choose to shrink it up to be that just that open source platform run by a foundation. We decided fairly early on that we would just all be free to pursue our own visions and work together on that foundational element. Cool. Yeah. Thank you.